Considerations of autonomic nervous system. So first, we'll study about the central nervous system. Means a rough outline of the central nervous system. So central nervous system is divided into how many parts?
Two parts.
Two parts. Which part? What are those two parts? Central nervous system and
Peripheral nervous system.
Okay. In central nervous system, what is there? In the central nervous system, one is
Brain.
and second one is
Cerebral.
spinal cord. Okay, brain and spinal cord. While is in peripheral nervous system, what comes under peripheral nervous system?
Afferent and efferent.
Afferent nervous system and
Efferent nervous system.
efferent nervous system. Afferent is also called as sensory nervous system and efferent is called as motor. Okay. So in case of the brain has different functions. What are those functions? First, functions of the brain.
Receive sensory information.
Receive the sensory information, then
Stores memory.
it will process the sensory information, it will store the memory, it will generate the thoughts, emotions. Those all are the functions of the brain. Then we have the spinal cord. What is the function of the spinal cord? It conducts the impulses to and from the brain. It also controls the reflex activities like knee jerk. That is an example of the reflex activity, where the impulse goes only up to the spinal cord. Okay, that is the function of the spinal cord. Then we have the afferent neurons, and afferent is nervous system and efferent. In case of the afferent nervous system, sensory, the information will come from
Sensory to
sensory
CNS.
organs to the
CNS.
So sensory organ to CNS. While in case of efferent,
CNS to sensory.
CNS to sensory organs. So now this one efferent motor system is divided into two parts further. Which one? One is autonomic nervous system, and second one is
Somatic.
somatic nervous system. Somatic is
Voluntary.
voluntary in nature. Okay, whereas autonomic is
Involuntary.
in nature. This is the involuntary nervous system, and it's further divided into two types. What are those types? Sympathetic nervous system and
Parasympathetic.
parasympathetic nervous system. What is the function of the sympathetic nervous system?
Fight.
Their function is fight,
Flight.
While as the parasympathetic nervous system has the function
Rest
of
and digest.
Rest and digest. So this has different names than parasympathetic or sympathetic nervous system. So man, we have to study about the autonomic nervous system. Okay. So this is the autonomic nervous system. So we have to give a specific focus on these three: sympathetic nervous system and parasympathetic nervous system. So if we will go to the first, sympathetic and parasympathetic, we will study them side by side. So sympathetic nervous system and parasympathetic, they have different origins. Parasympathetic nervous system. So sympathetic nervous system, if I will go for the origin, what is the origin of the sympathetic nervous system? Dorso-lumbar, or we can say thoracic lumbar. T1 to L3. T1 to L3. Thoracic plus lumbar. Okay. So the origin is dorso-lumbar. What is the origin of parasympathetic nervous system? Craniosacral. Means the nerves originate from the cranium and the sacrum. From cranium, which kind of cranial nerves? 3, 7, 9 and 10. These are the cranial nerves which will originate from the parasympathetic nervous system. That's why it's called as craniosacral. And sacral, S2, S3 and S4. Okay, these are the nerves from where these things will originate. So in case of sympathetic nervous system, dorso-lumbar, it is craniosacral. Now in sympathetic nervous system, there are two fibers. One is preganglion, second one is
Postganglion.
So ganglion is the junction where the neurons meet. Okay. So here there will be a junction. In case of the sympathetic nervous system, there are two types. Preganglionic nerve fibers will be short, whereas postganglionic nerve fibers will be long. Okay. So preganglionic nerve fiber is short, postganglionic nerve fiber is long. You can remember preganglionic nerve fiber is short in sympathetic nervous system. S means short. So preganglionic nerve fibers will be short. Postganglionic nerve fibers will be long, then they will be effector organs. So we can say that ganglion in case of the sympathetic nervous system is close to the brain and spinal cord. Okay. While in this case, in case of the parasympathetic nervous system, what will happen? Preganglionic nerve fibers are long and postganglionic nerve fibers are short. That means the ganglion in case of the parasympathetic nervous system is located away from the brain and spinal cord, while in this case it is located close to the brain and spinal cord. Now if we will go to the functions, sympathetic and parasympathetic nervous system have different functions. They will means their actions will act either on heart or then eye, heart, then lungs, then we have gastrointestinal tract, or we can write here as stomach, then we have liver and
Bladder.
Now they have opposite functions. The functions of the sympathetic nervous system will be opposite to that of the functions of the parasympathetic nervous system. For example, in case of the eye, what is the function of the sympathetic nervous system? Because sympathetic nervous system works in fight or flight conditions. Okay? So it works in fight or flight conditions. That means the effect of the sympathetic nervous system on the eye during the fight or flight condition will be mydriasis. And what is mydriasis? Dilation of pupil. Okay? So it will dilate the pupil. What will be the effect of sympathetic nervous system on the heart? It will increase the heart rate. Because when you are in fight or flight conditions, your heart will beat fast, so that will increase your heart rate. So there will be increase in the heart rate when the sympathetic nervous system is stimulated. Okay? Third one is lungs. What will be the effect on the lungs? It will cause bronchodilation. Bronchodilation. Okay, bronchodilation is dilation of the bronchi, which will cause increase in the respiratory rate. Respiratory rate is increased. In case of the liver, what will be the effect of the sympathetic nervous system? Release of
Glucose.
In case of stomach, it will decrease the secretion. Bladder, it will decrease the urinary output. Okay, so these are the functions. So it will stimulate eye, heart, lungs, and liver, while it will decrease the secretions in case of stomach and decrease the urinary output in case of the urinary bladder. Okay. Then we have the parasympathetic nervous system. What will be the effect on the eye? Just the opposite effect of the sympathetic nervous system. That means on the eye it will be meiosis. On the heart it will be decrease in the heart rate. Lungs,
bronchoconstriction.
Constriction. In case of liver, it will store glucose. In case of stomach, the secretions will increase. In case of bladder, the urinary output will increase. So the questions can come like this. In case of the sympathetic nervous system, what is the effect of the sympathetic nervous system on the bladder? It will decrease the urinary output. While in case of parasympathetic nervous system, it will increase the urinary output. So these effects are just opposite to each other. Okay. So after this sympathetic and parasympathetic nervous system, then there is cholinergic drugs. And before cholinergic drugs, I will explain you one more topic, that is how the acetylcholine is synthesized in our body. Okay. So for example, this is the example of the neuron. Okay. So this is the neuron. First, and this is for example mitochondria. From mitochondria, what will come? Acetyl coenzyme A. Acetyl coenzyme A plus it will react with the choline, which is uptaken from the outside. So when these acetyl coenzyme A plus choline, when they will mix together, what they will form? Acetyl coenzyme A or acetyl choline. Okay. So it will form ACH, acetyl choline, and which is stored in the synaptic vesicles. This is the synaptic vesicle. Synaptic vesicles. So this acetylcholine will be stored in the synaptic vesicles and it will be released by the stimulus. When the stimulus comes from the brain, then the stimulus will activate this and the acetylcholine, it will merge with these vesicles, will merge with the membrane, and then this acetylcholine ACH will be released. Then this ACH will act on two types of receptors, either on nicotinic receptors, either on muscarinic receptors. Okay. Now this is the normal function of the acetyl coenzyme A, which comes from the mitochondria, reacts with the choline which is uptaken from the outside. Okay. Now there is one question, for example, here the release of the acetylcholine from the neuronal end, it's blocked by one chemical. What is that called? Is botulinum toxin. So this question is often asked in the examinations. So this release, okay. then this acetylcholine will act on either nicotinic or muscarinic receptors. The extra acetylcholine, where it will go? It will be converted to acetyl coenzyme A plus choline by anticholine cholinesterase. Okay, there is an enzyme is called as cholinesterase, which converts it into acetyl coenzyme A plus choline. Then this acetyl coenzyme A plus choline, this will go back by a transporter. There is a presence of transporter here. That transporter will take the acetyl coenzyme A plus choline back. Then it, again this process will continue. Okay. So here one enzyme acts if we want to if we don't want to convert the acetyl coenzyme A into acetyl coenzyme A plus choline. There are drugs which act here. What are those called as? Anticholinesterases. Anticholinesterases. So anticholinesterases, they will provide this degradation of acetyl coenzyme A into acetyl coenzyme A plus choline. So if we want to increase the concentration of the acetyl choline in our body, we have to stop this process. Okay. So we have to give the anticholinesterases, which we will study further. Okay. Now there are other receptors also here. There is M2 receptor, this is called as the autoreceptor. This is present here. Okay. And there is one more enzyme or one more chemical substance which stops the uptake of this choline by the synaptic vesicles. What is that called as? Vesicles. So it also inhibits the uptake of the acetylcholine into the vesicle. Okay, so this was about this. Now we have two types of receptors here: nicotinic receptor and muscarinic receptor. So in case of the nicotinic receptor, how many types of receptors are here? Two. One is NN and second is NM. So nicotinic receptor is which type of receptor? Ligand-gated ion channel. Okay. So ligand-gated ion channel, in this the subunit is having 2 alpha, 1 beta, 1 gamma, and 1 delta subunit. So 5 subunits are present here. Okay. So we have NN and NM receptors. NN receptors, where they are located? Location of NN receptors. Adrenal medulla,
CNS ganglion,
autonomic ganglion. Okay. And NM neuromuscular
junction.
Then after this we will study about the classification. That classification will be based on this. There are different types of receptors, will be based on this. So NN receptors, they are having agonists as well as antagonists. What is the agonist of NN receptor? Agonist DMPP, dimethyl phenyl piperazine. Okay. Antagonist
Trimethylene.
hexamethonium,
Trimethylene.
trimethophone. Okay. While as this was in case of NN. While as in case of MM, what is antagonist? Agonist is PTMA, phenyl trimethylammonium, and antagonist is
Alpha bangarotoxin
and D-tubochroid. So these are the antagonists. Okay. Now second one type of receptor is M receptor. So in case of M receptors, there are different subtypes: M1, M2, M3, M4 and M5 are located in central nervous system. M1 is located in gastric gland, that is the first location. Second, intestinal muscle. Which muscle? Smooth muscle. And CNS. M2 receptor is mainly located in
Heart.
So M2 receptor is located in heart. Then
CNS.
visceral smooth muscle and central nervous system. M3 is located everywhere apart from the central nervous system. It's located in the eye. It's located in the bronchi. It's located in the
bladder.
gastrointestinal tract. It's located in the
GIT.
bladder. Okay.
Blood vessels.
So these are the locations of the nicotinic receptors and muscarinic receptors. Their agonists and antagonists. Okay.